In this video, I'll talk about different types of asymptotes. So when do we get asymptotes in a function? When you have a function like this, f of x, right, equals to ax to the power of n plus the rest of the term divided by bx to the power of m plus the rest of the term, right? You have a numerator and the denominator. Now, let's talk about the asymptotes. The first one I want to talk about is vertical asymptote. So when do we have vertical asymptote? We usually can set the denominator equal to 0. Right? And then find the value of the x here. Now, because usually you cannot divide anything by 0. So denominator cannot be 0. Now, if you can cancel something out with the numerator and the denominator, then whatever that can be cancelled out, that's just a whole there. But whatever that cannot be cancelled out with the numerator, then you will have a vertical asymptote there. Okay. Now, next, horizontal asymptote. So what's the rule for horizontal asymptote? Over here, we look at the highest degree of power in the numerator and the denominator. Let's say n is the highest degree of power in the numerator and m is the highest degree of power in the denominator. Then, if n is less than m, the horizontal asymptote will be y equals to 0. If n is equal to m, then the horizontal asymptote will be the leading coefficient in the numerator divided by the leading coefficient in the denominator, which is a over b. Y equals to a over b. If n is greater than m, there will be no horizontal asymptote. Okay, now, the next one we want to talk about is oblique asymptote. So how do we find oblique asymptote? It's when the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator. In this case, right, n has to be exactly 1 greater than m. So we can say that if n minus m is equal to 1, we will have a oblique asymptote. Now, how do we find the oblique asymptote? Let's take this function here, right? We will just do a long division on this. So we have this ax to the power of n plus the rest of the term divided by bx to the power of m plus the rest of the term. Now, here, whatever we get here, that's the oblique asymptote. So regardless whether there's remainder or not, this is the oblique asymptote. Now think about that, right? If the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator, and when you do a long division on this will have an x variable with the highest degree of power of 1. Because an oblique asymptote is a slender straight line. It's slender straight line. So this needs to be an equation of x, right? With a highest degree of power 1. So it has to be like a line. That would make sense. Okay, so now we have talked about the rules for this asymptote here. Let's talk about different examples and try to identify all the asymptotes in those examples. Okay, so let's look at the first example. Let's say f at x is equal to 1 divided by x minus 2 plus 2. Okay. Let's see, we have vertical asymptote. Okay, I will just write vertical, but I'm talking about asymptote here. Okay, let me just write asymptote as well. Okay, here. Since there's nothing you can cancel out between the numerator and the denominator, you can just set the denominator equal to 0, right? And x equals to 2 is the vertical asymptote. Now, do we have horizontal asymptote? Now, to look at it like this, right? 1 can be seen as x to the power of 0. So we can look at this function like this. f of x equals to 1 times x to the power of 0, right? Divided by, now, x minus 2. Now, x has a degree of power 1 minus 2, right? Plus 2. Now, look at the rules here. The degree of power in the numerator is less than the degree of power in the denominator. So the horizontal asymptote is y equals 0. As you can see, 0 is less than 1. So we have the horizontal asymptote at y equals 0. However, there's a plus 2 here in this function. So it will shift the function up by 2 units. So the horizontal asymptote is y equals 0 plus 2. Then y is equal to 2 is the horizontal asymptote. Now, do we have oblique asymptote? Okay. We can only have either horizontal asymptote or oblique asymptote. Since we have horizontal asymptote already, we cannot have oblique asymptote. Now look at the rules for oblique asymptote that we just talked about. Right? The degree of power in the numerator has to be exactly 1 greater than the degree of power in the denominator. In this case, it's not the case, right? So there's no oblique asymptote. Okay, now let's look at the second example. Say f of x equals to x plus 2 divided by x plus 1. Do we have vertical asymptote? Now, first of all, can you factor this further? No, you cannot. So that's it, and nothing can cancel out. Okay, in that case, you can just set the denominator equal to 0. Then x equal to -1 is the vertical asymptote. Because you cannot divide the denominator by 0, right? So x cannot be equal to -1. Okay, how about horizontal asymptote? Now, notice that the highest degree of power in the numerator and the denominator are both 1, right? So they're equal. Look at the rules here. When n is equal to m, the horizontal asymptote is the leading coefficient in the numerator divided by the leading coefficient in the denominator. In this case, both leading coefficient is 1 and 1. Right? Okay, so the horizontal asymptote is y equals to 1 over 1, y equals to 1 is the horizontal asymptote. Now again, since we have horizontal asymptote, we will not have oblique asymptote. Because this is 1 and 1, right? So the highest degree of power in the numerator is not 1 greater than the highest degree of power in the denominator. So we don't have oblique asymptote. No oblique asymptote. Okay, third example. f of x equals to x squared plus 3x divided by x minus 2. Do we have vertical asymptote? Now let's see, can we factor this further? Yes, we can. Let's try it. Now factor the x out as a common factor. We have x times x plus 3 divided by x minus 2. Now that's nothing you can cancel out. So that's it. Okay, so you can set the denominator equal to 0. Then x equals to 2 is the vertical asymptote because x minus 2 cannot be 0 really in this function because you cannot divide by 0. Then x equals to 2 is vertical asymptote because you cannot divide, because x cannot be equal to 2 in this case. Okay, how about horizontal asymptote? Now, look at the rules here, right? This degree of power is 1. If the degree of power in the numerator, the highest degree of power in the numerator is greater than the highest degree of power in the denominator, there's no horizontal asymptote. So in this case, 2 is greater than 1, so no horizontal asymptote. Do we have oblique asymptote then? Now look at the rules here. If the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator, you have oblique asymptote. And to find the oblique asymptote, you have to do the long division. Over here, 2 is exactly 1 greater than 1. So you will have an oblique asymptote. Let's do a long division on this. Okay, so here. So that was x squared plus 3x divided by x minus 2. Okay, now x times x will give you x squared here. Now negative 2 times x is negative 2x. Okay, x squared minus x squared is 0. 3x minus negative 2x is 5x. Now, times 5, right? X times 5 is 5x. Negative 2 times 5 is negative 10. Now, 5x minus 5x, 0. 0 minus negative 10 is 10. Can you divide x minus 2 into 10 anymore? No, you cannot. So this will be the oblique asymptote. It doesn't matter you have remainder or not. This will be the oblique asymptote. So I can say that y equals to x plus 5 is the oblique asymptote. Okay. Next example. Okay, now let's say, okay, example 4. F at x equals to x plus 1 divided by x squared minus 2x minus 3. Now, first of all, I think we should just factor the denominator, see if we can cancel anything out. Maybe not. Maybe we can. We'll see, right? Now, let's do this. Factor x squared minus 2x minus 3. Okay, find two numbers. When you multiply together, give you negative 3. When you add together, give you negative 2. That will be 1 and negative 3. So that is equal to x plus 1 times x minus 3. Okay, rewrite this function. The denominator is this. Can you cancel anything out? Yes, you can. X plus 1 and x plus 1 cancel out. What you have left is 1 over x minus 3. Okay, in that case, if you set x plus 1 equals 0, okay, so normally you will have to set, okay, for vertical asymptote, right? Vertical asymptote. You have to set the denominator equals 0. In this case, it's like x plus 1 times x minus 3 equal to 0. But x plus 1, right? This one has to be like equal to 0, right? But the thing is, it cannot be equal to 0, right? So that means x cannot be equal to -1. But in that case, right, since this cancel out, right, with the numerator, we can say that x equals to -1. That's a whole there. At x equals to -1. So not a vertical asymptote. But x minus 3 is not cancelled out with anything in the numerator. So we can set x minus 3 equal to 0. And the vertical asymptote is x equal to 3. Okay. Now, next, horizontal asymptote. Do we have one? Okay, let's look at the highest degree of power here. So it will be 1 and 2. Well, based on the rules that we talk about, the highest degree of power in the numerator is lower than the highest degree of power in the denominator. So we do have a horizontal asymptote. And that is y equals to 0 in this case. Okay, since we have horizontal asymptote, we don't have oblique asymptote. So no oblique asymptote. Okay, example 5. F at x equals to, now, x cubed minus 2x squared minus 5x plus 6 divided by x squared plus x minus 6. Okay, in this case, the first thing we should do is factor both the numerator and the denominator. See if we can cancel anything out. Okay. Now, first, factor the numerator. So we will say, okay, factor x cubed minus 2x squared minus 5x plus 6. Now, in this case, how do I factor this? Now, first of all, find the divisor of 6. That will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Divide by the divisor of 1 here, the leading coefficient. Will be plus or minus 1. Okay, let's try like 1 divided by 1, which is positive 1, right? So let's try x equal to 1 then. Try x equal to 1. See if we can make this equal to 0. If it does, that means x equal to 1 is a root. Okay, so let's try this. 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. What's that equal to? Now 1 cubed is 1, minus 2, negative 1. Negative 1 minus 5 is negative 6. Negative 6 plus 6 is 0. Okay, so that means x minus 1 is a root. Then what do we do? Okay, we can do a long division, right, on this as well to see how we can break this out. Okay, so x cubed minus 2x squared minus 5x plus 6. X cubed minus 2x squared minus 5x plus 6. Now, divide by x minus 1. Okay. Now, this will be x squared, right? X squared times x is x cubed. Minus 1 times x squared is minus x squared. Now, x cubed minus x cubed is 0. Negative 2x squared minus negative x squared is negative x squared. Now, this minus 0 will just bring it down. Okay, next, x times negative x will give you negative x squared. Negative 1 times negative x is plus x. Okay, now, negative x squared minus negative x squared is 0. Negative 5x plus minus x will be negative 6x. Now, plus 6, right? Because that's 0 anyway. Okay, in that case, minus 6, right? minus 6 times x is minus 6x. Minus 1 times minus 6 is plus 6. Okay, no remainder. That's good. Now we can rewrite this as, this cubic function as x minus 1 times x squared minus x minus 6. Okay. In that case, can you factor this further? It's a quadratic equation here. Let's see, right? If you can find two numbers when you multiply together given negative 6, because that's leading coefficient 1. When you add together given negative 6, or negative 1. I mean negative 1. Okay. That would be 2 and negative 3. So that is equal to x minus 1 times x plus 2 times x minus 3. Okay, so that's fully factored. Now, let's factor the denominator, x squared plus x minus 6. Okay, find two number. Okay, because that's leading coefficient 1, right? So find two number, when you multiply together give you negative 6, when you add together give you plus 1. That would be negative 2 and 3. Okay, so I can write this as x minus 2 times x plus 3, right? That's the factor form. Now, I can rewrite this function here. That's equal to f at x equals to this, right? This divided by this. Now, can you cancel anything out here? No, you cannot. Okay, now, to find the vertical asymptote, let the denominator equal 0. Because they cannot be equal to 0, really. You cannot divide anything by 0. Okay, then x minus 2 equal to 0, right? X plus 3 equal to 0, then x equals to 2 is one vertical asymptote, and x equal to negative 3 is another vertical asymptote, because x just cannot be equal to 2 and negative 3 in this function. Okay, how about horizontal asymptote? Okay, because the highest degree of power in the numerator is greater than the highest degree of power in the denominator. You don't have horizontal asymptote here. No. No horizontal asymptote. Okay, do we have oblique asymptote then? The highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator. So we should have oblique asymptote. So let's see what it is. Here. Oblique asymptote. Let's do a long division on this. So x cubed minus 2x squared minus 5x plus 6 divided by x squared plus x minus 6. Okay, now you have to put x here. X squared times x is x cubed. X times x is x squared. Negative 6 times x is negative 6x. Now, x cubed minus x cubed is 0. Negative 2x squared minus x squared is negative 3x squared, negative 5x minus negative 6x plus x. Now 6 minus 0 is 6. Okay, next this will be negative 3, right? Times x squared will be negative 3x squared. X minus 3, x times negative 3 is minus 3x. Negative 6 times negative 3 is plus 18. Now, negative 3x squared minus negative 3x squared is 0. X minus negative 3x is 4x. Minus 18 is negative 12. Can you divide x squared plus x minus 6 into 4x minus 12? Not really, but doesn't matter. This is the oblique asymptote. Y equals to x minus 3. It's the oblique asymptote. Okay, next example. 6. f of x equals to x squared minus 2x minus 3 divided by x minus 3. Okay, let's factor the numerator first. See if we can cancel anything out. Okay, since the leading coefficient is 1, so 5 two number, when you multiply together, give you negative 3. When you add together, give you minus 2. That will be 1 and negative 3. So that's equal to x plus 1 times x minus 3. Okay, we can rewrite this function. f of x equals to x plus 1 times x minus 3 divided by x minus 3. Can you cancel anything out? Yes, you can. X minus 3 and x minus 3. Right? So what you have left is f of x equals to x plus 1. Now, notice that since x minus 3 cancel out, right? There's no vertical asymptote. But there will be a hole at x equal to 3. Because, again, right? You cannot have denominator really equal to 0. We only set it equal to 0 to find out what the x value is that has a vertical asymptote or hole. But in fact, you cannot have anything divided by 0. So there will be a hole at x equal to 3 because it cancels out. So no vertical asymptote. No vertical asymptote. Okay. Now, since this is a straight line left with a hole at x equal to 3, we don't have to look for any more horizontal asymptote or oblique asymptote. Okay, so that's it for this. Okay, next example. 7. Let's say f of x equals to x squared plus 2x plus 1, all divided by x squared plus 4x plus 4. I think what we should do is factor both numerator and the denominator first. See if we can cancel anything out. Since the leading coefficient is 1 here, right? Find two numbers. When you multiply together, give you 1. When you add together, give you 2. That will be 1 and 1. So that is x plus 1 times x plus 1. Next, factor the denominator. X squared plus 4x plus 4. Find two numbers. When you multiply together, give you 4. When you add together, give you 4. There will be 2 and 2. So that is x plus 2 times x plus 2. Okay, Now I can rewrite this. F of x is equal to here x plus 1 times x plus 1 divided by x plus 2 times x plus 2. Okay, can you cancel anything out? Not really. You cannot. Okay, that's also the same as x plus 1 squared divided by x plus 2 squared. Okay, now, do we have vertical asymptote? Now what we can do is set the denominator equal to 0. Right? Take the square root of both sides, x plus 2 equal to 0, then x equal to -2 is the vertical asymptote. Do we have horizontal asymptote? Now, since the degree of power, the highest degree of power in the numerator is exactly the same as the highest degree of power in the denominator. So the horizontal asymptote is the leading coefficient in the numerator divided by the leading coefficient in the denominator. So it's 1 over 1. Y equals 1. Okay, since we have horizontal asymptote, we don't have oblique asymptote. As you can see, the highest degree of power are the same. So it's not like it is 1 here greater than the highest degree of power here. So no oblique asymptote here. Okay, no oblique asymptote. Okay, next example. Example A. Let's say f of x equals to x cubed minus 4x squared plus x plus 6 divided by x minus 1. I think we should factor the numerator first, see if we can cancel anything out here. Okay, now we need to find the divisor of 6, which will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, right? Divided by the divisor of 1, which will be plus or minus 1. Okay, so in this case, let's try -1, right? Let's try x equal to -1. Let's see if we can make this equal to 0. If it does, then x plus 1 will be a root. Okay, let's try that. -1 cubed minus 4 times -1 squared plus -1 plus 6. Okay, what's that equal to? This is -1, minus 4, -5, minus 1, -6, plus 6, 0. So that means x plus 1 is a root. So what do? We will do long division here too, right? To see how we can break this out further, right? So let's do a long division here. X cubed minus 4x squared plus x plus 6 divided by x plus 1. Okay, so this will be x squared. Now x times x squared is x cubed minus x squared. Now this will be 0, cancel out. Then this minus this will be -3x squared. Now plus x plus 6. Okay, sorry, this is plus, right? So that will be minus 5x squared. Next, minus 5 times x is minus 5x times x is minus 5x squared. This will be minus 5x. This will cancel out. What I'm left here is this minus negative 5x is 6x plus 6. So if I plus 6 here, that will be 6x, right? Plus 6. Okay, exactly equal to 0. No remainder. That means I can rewrite this as x plus 1 times x squared minus 5x plus 6. So x cubed minus 4x squared plus x plus 6 equal to x plus 1 times x squared plus 5x plus 6 minus 5x. Now, can you factor this further? I think so. Try it. Now, since the leading coefficient is 1, find two numbers. Okay, I can erase this. Find two numbers. When you multiply together, give you 6. When you add together, give you negative 5. That will be negative 2 and negative 3. So that's equal to x plus 1 times x minus 2 times x minus 3. Okay, now we can rewrite the function. F of x equals to this x plus 1 times x minus 2 times x minus 3 divided by x minus 1. Can you cancel anything out here? No, you cannot. So you can set the denominator equal to 0 to find the vertical asymptote. X minus 1 equal to 0, then x equal to 1 is the vertical asymptote. Okay. How about horizontal asymptote? In this case, the highest degree of power in the numerator is greater than the highest degree of power in the denominator. So that's no horizontal asymptote. Do we have oblique asymptote then? But the highest degree of power in the numerator is not exactly 1 greater than the highest degree of power in the denominator. So you don't have oblique asymptote either. Because if you divide this by this, if you divide the numerator by the denominator, you will have x squared as the highest degree of power. But that's not a line. It has to be just x to the power 1. So that's no oblique asymptote either. So in this case, horizontal asymptote? No. No oblique asymptote either. Okay. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.